Okay, so continuing with IS number 15 on confidence intervals for means, we're going to start here with number 12. We're actually going to talk about how to find a t-star value, a critical value from the t-distribution. So it asks, what t-star is needed for this confidence interval? Remember that we are trying to compute a 95% confidence interval for the mean. It says to use table A3 and the degree of freedom equal to n-1 to find it. Okay, so those are two new things. So first of all, table A3 has been posted in the class materials section for today. It looks like this. It says table A3 at the top, t-distribution, critical t values. So let's investigate this a little bit. Over here on the left, where we used to see z-scores in table A2, now we see degrees of freedom. So that's why we needed that definition of degrees of freedom, that they are n-1. Well, that's very easy to calculate. We're going to plug in our sample size and subtract 1. And then let's see what else is in table A3. It says area in one tail versus area in two tails. The area in one tail can be helpful, but we'll almost always use area in two tails. So we're thinking about when we have a 95% confidence interval, the 95%, let's draw my little sketch here real quick, would be in the middle. So this is my 95% in the middle. So the area in the tails is my 100% minus 95%, or 5%, which of course, these aren't given in percentages, they're given in proportion, so we convert that to a decimal, 0.05. Okay, so let's go ahead and write down what we'll actually need here. So first, the degrees of freedom is it's the simplest part. I'm going to do it first. I'm going to go ahead and write out degrees of freedom to make sure that you know what I'm talking about. But in the future, I will not write this out. I will abbreviate it as DF. Okay, so the formula for that is equal to n-1. Our sample size is 30, so this is 30 minus 1, which is 29. Pretty straightforward. Okay, so we're going to look for the row that has degrees of freedom 29. And then, again, my confidence level was 95%. So this is my area in two tails, 0.05. Area in two tails. We'll get really used to this calculation, right? It's the 100% minus your confidence level and convert it to a decimal. That's your area in two tails. Okay, so I'm gonna look at table A3 and use my 0.05 area. I'm just gonna say in tails because there's only two, instead of tail for just one tail. I'm gonna use that and the degrees of freedom equal to 29 to get my t-star value. Okay, let's look over at our table. So I come to degrees of freedom and I look for 29, and then I come back up to the top and I see area in two tails of 0.05. So I'm gonna follow that down. If I had two fingers, this would be easier. Okay, so 29 lines up with a 0.05 area in two tails to give us a t-star value of 2.045. So 2.045. Okay. So that's how I find my critical value, right? This is similar to the z-star value from confidence intervals for proportions, but now we have t-star because we're using the t-distribution for means. There is another way to calculate that, and I'm going to go ahead and write that in for us. It uses one of those inverse functions. So here's kind of our other option. We can use INVT. INVT. So this is the inverse t distribution. So if I go to my calculator, I have to go to the distribution again. So second distribution. There's my inverse norm that I would use before to find z-star critical values. So inverse t, the fourth one, is what I want. It asks for an area and a degrees of freedom. Okay, so my area is again a left area. So it's my 95% plus the left tail area out here. So that would be my 0.05 divided by 2, which would be 0.025, this little left tail area. So if I add those together, my 0.025 plus my 0.95, I'm actually going to write that in here, 0.025 plus 0.95. That'll add together to give me 0.975, won't it? And then my degrees of freedom are 30 minus 1 or 29. All right. Let's see. Okay, so I pasted it in and calculated it, and it gave me 2.045, which exactly matches what I got from the table. So either option is acceptable. Again, I'm going to put in here that I did 0.025 plus my 0.95. You could just write 0.975 if you want to, but I'm trying to make it really clear where that's from. And then degrees of freedom of 29 gives me 2.045. And again, that's my T-star value. So 2 options on how to do that. Either use the table or use that inverse T function. The problem with the inverse T function is that you just have to remember to use that left tail area. In addition, it's kind of easy to make a mistake. So if you want to use the inverse T function, I always suggest checking it with the table. Okay, so now we're going to calculate our margin of error using T-star in the critical, or in the standard error. So if you remember, the margin of error is always equal to whatever your critical value is times your standard error or standard deviation. Okay, so the critical value we're using is T star, and we just learned that the standard error, so it's back on the previous page, is equal to S divided by the square root of N. Okay, and of course we use margin of error, or we use E to denote margin of error. So E is equal to T star times S divided by the square root of N. So let's plug into that. We know that our T star value is 2.045. We are going to multiply that by S, which was 0.0817. That was given to me on the previous page, divided by the square root of N, so divided by the square root of 30. Okay, so let's calculate that out here in my calculator. Oops, got a little shadow there. Okay, so I can type that whole thing in. I could type in 2.045 times 0.0817 divided by, use second square root, 30. Okay, plug that in and I get 0.0305. 4 decimal places is good to round to. So my margin of error is 0.0305. If I wanted to convert that to a percentage, it's essentially saying it's a margin of error of 3 percentage points, right? Okay, so now let's calculate the 95% confidence interval using the formula for confidence intervals, point estimate plus or minus margin of error. So I know my point estimate is that sample mean, which was 11.1921. And then I'm going to add and subtract my margin of error, which I just found was 0.0305. Okay, so if I subtract first, I have 11.1921 minus, I'm just going to go up and select that margin of error that I just calculated, just because I don't want to lose any rounding. If I enter that in, I get 11.1616 if I round. 11.1616, comma. Now, instead of retyping all of that, I can just go back up and select that command, but change, using the arrows to get over to it, the minus sign to a plus sign. Okay, I got 11.2226. So 11.2226. All right, done. My confidence interval has been calculated. Keep in mind your book also does mention one other way to write the confidence interval, so I'm going to go ahead and put that in there. It's the lower confidence interval limit, so 11.1616, oh, sorry, not comma, is less than what you're trying to estimate, which is mu, is less than the upper confidence interval limit of 11.2226. Okay, so all different ways to state your confidence interval. I'm probably going to use this one most often, but your book does mention this one. Okay, so then it says to interpret the interval. This is very similar to what we did for proportions. It's that same sentence. So we are, and then we fill in our confidence level. So 95% confident that the interval, and then we fill in what our interval limits were. So from, don't forget, we can use units here. So from 11.1616 grams to 11.2226 grams. then we say captures, right? Because the mean is fixed. The mean already exists. All those Oreos already exist. We just don't know what it is. So what is changing, or what can change depending on the sample, is the interval size. So we're seeing if the interval captures, and then we say the parameter, which for us in this case is the true mean weight of Oreos. Okay, and then it says write a specific formula for a confidence interval for a population mean. Well, basically we're just putting together all the pieces that we've learned so far. The point estimate for means is x bar, so we start with that, plus or minus the margin of error we have figured out is our critical value t star times the standard error, which for the sampling distribution of sample means is s divided by the square root of n. Again, I could have written s of x, I just felt like it was getting too many symbols in there. Okay, so that is our formula. And then it asks us, and this is where, we're going beyond the interpretation of our confidence interval. We're asking a question, or we're testing a claim based on the interval. So it says, according to Nabisco, an Oreo weighs 11.3 grams. Oh, I'm already thinking, that's not in my interval. It says, does our confidence interval provide convincing evidence that the true average weight is less than 11.3 grams? So I'm reading my question carefully. Do I have convincing evidence that the true average weight is less than 11.3 grams? Well, 11.3 grams is not within this interval, right? If I rounded this a little bit better, it would be 11.16 to 11.22. 11.3 is greater than all of those. Or I can reverse that. I can say this entire interval is less than 11.3. So is there convincing evidence that the true average weight is less than? Yeah, we're 95% confident that this interval captures the true weight, and all of these values are less than 11.3. So let's say that, yes. Our confidence interval, or it, provides convincing evidence that the true mean weight of Oreos, should make that capital, so of Oreos is less than 11.3 grams. Notice I'm basically just quoting the question. Since, and this is where I have to do my thinking, since the plausible values, remember my interval is a set of plausible values, so I'm going to specify that those come from the interval, are all, since the plausible values are all less than 11.3 grams. Now, if 11.3 had been my interval, I would not have convincing evidence. I wouldn't be able to say that the average is for sure 11.3, but I would just not have convincing evidence. But since 11.3 is outside of that interval, I do have convincing evidence. Okay, so before I move on to the big ideas, I just kind of want to point out some important things on this page. First of all, we have some new things, table A3, and the formula for degrees of freedom equal to n minus 1. That's true for the confidence intervals for means. We also talked about a new way to calculate margin of error, and thus a new way to calculate our confidence interval. Now, it's still the same generic idea, point estimate plus or minus margin of error, but the specific formula is different now, and this is the most important part of what we figured out today. Okay, so there are just 3 more things that I want to point out on the previous page that I forgot about, sorry. So I'm going to flip back over to that. All right, so I wanted to point out that number 6, this actually contains condition number 1 for us, which is the random sample condition. And then number 8 is condition number 2. Right, we actually just constructed a confidence interval, and of course we had to check our conditions. So we checked random, we checked 10%, and then number 10 is our third condition. So this is condition number 3, and that is that the the sampling distribution of x bar can be approximated by a normal distribution. We use the CLT. I'm about to explain some other ways that we can determine whether or not a normal model is a good fit. Okay.